Hi guys, so this is part 2 of that spreadsheet where you're going to be looking at cholesterol levels in men and women. So I just grabbed, this is an old study from the 60s, but it had the total blood serum cholesterol levels. This is in milligrams per deciliter of blood, if you care. Turns out now that what matters is the level of your good and bad cholesterol, but what I have here is a sample. In your case, you're going to have, I think I put 200 observations of the cholesterol levels of men or women. This guy is really, really high. And so the first thing you're going to do is, in this area, you're going to calculate the average for the men and the women, the median, the min, the max, and then the standard deviation of the sample. So it's going to be, again, this, we're going to use this standard deviation of the sample, and we'll do it here for the men and so on. So you should get 44.51 and so on. Okay, you're now going to put in this case, what you're going to do is you're going to square the value that you get here. And in this case, you're actually going to use the formula of variance, which is equal to this, variance, and you want to use this sample one. Okay, and then here you're going to input the values from, you're going to go to data analysis and run the test, and you're going to paste them here. Okay, so to show you what that's going to look like when you're done, I go to the demo. I've named mine cholesterol men and cholesterol women. You don't have to do that. Okay, and so the mean here, I'm just using this average formula. The median, you're also going to put in the difference. You've got the min and the max, which is just the min formula, the max formula. So then here's the standard deviation of the sample, as I mentioned before. Okay, this one just squares the prior one, so I just raise it with that caret 2 for squared. And in this one, I actually use the variance formula. These should come out to be identical. Okay, they should also be identical when we do the samples. You've got this mean. If I were to take that out, that's 744. They should be the same as should the variance. Okay. Then we've got the t-test. So I'm here assuming equal variance. I created this sample, so I happen to know what the standard deviation and the variance are. So the standard deviation for the men was supposed to be around 45, and this one was supposed to be around 50. And so we could use the equal variance. As I mentioned, we generally don't know if they're going to have an equal variance or not, so I'm having you run it both ways. So you're going to run data assuming equal variance and then assuming unequal variance. You'll notice that the t-stat is between the two, but not very much because this is a large sample. And so if we wanted to argue, are they different, we're going to put in the two-tailed or the two-sided t-test. It is statistically significant in both cases because that is less than 0.05. It's 0.0425 there and 0.0435 down here. You say, which one would you use in practice? I normally use this unequal variance just because I don't want to assume it. And if I have a fairly decent size sample, this one will converge on that one. If in fact they have equal variances. So I use a program called Stata, which makes it really, really easy for me to run these tests, and I've just posted. Unfortunately, the test in Excel equal what my statistical program says, which is that this is 0.213, which is that right there, or 0.0425, which is that right there, and our t-stat is, it says 2.0409, and this says 2.0408, and we get, of course, the exact same mean and median there. So this is with assuming equal variance. This is assuming with unequal. So we get that same 2.0217, 0.0435. Okay, so to get this, all you do for the equal variance, again, we're going to go data analysis, and we're going to go down for the unequal variance, or for the, let's do the equal variance. Okay. And then in this case, we need to make sure we've selected the men. We'll go ahead and select the men, including the label. Then on the women, I've got B6 to B106. This is on the demo. You need to, of course, select yours. We hypothesize the difference at 0. Labels, the alpha is 0.05. I'm putting it on a new worksheet, then I'm just going to paste it in. So we hit OK. for men and women, and then all I did was take this and paste it right here. So you're going to do the same thing so that you can paste it. I've already put the heading, so you can just paste it here and here. You can paste right over that and then just bold it. But of course, you're going to need to put in the formula right here. So hopefully that helps, and this shouldn't take that long.